Welcome, dear friends, once again into VK Jain Sir ki MEP classes. The current series I will be discussing underground electrical power distribution and cables. This is mostly on underground. So listen carefully. Friends, this particular series is about cables. So let me define what cable is. Cable is a general name given to an insulated conductor or group of conductor and is extensively used in indoor and outdoor underground distribution systems. Nearly 50 to 60% of total electrical faults occur in overhead transmission lines because here the wire runs overhead and bare. This could be brought down to as low as 10 to 20% if underground insulated cable system is resorted to. Previously, voltage of transmission was a limiting factor, but now cables have been manufactured for voltages as high as 275 kVA in insulation grade known as cross-linked polyethylene XLP insulated cables. Friends, following are the main advantages of underground power cables. First, less subject to damage from severe weather conditions, mainly wind and freezing. Second, greatly reduced emission into surrounding area of electromagnetic fields (EMF). All electrical current generate EMF, but the shielding provided by the earth surrounding underground cable restrict their range and power. Third, underground cable need a narrower surrounding strip of about 1 to 10 meters to install, whereas overhead lines require a surrounding strip of about 20 to 200 meters wide to be kept permanently clear for safety, maintenance and repair. Fourth, underground cables pose no hazard to low-flying aircraft or to wildlife and are significantly safer as they pose no shock hazard except to the unwary digger. Friends, disadvantage of UG power cables. Undergrounding is more expensive since the cost of wiring cables at transmission voltage is several times greater than overhead power lines, and the life cycle cost of an underground power cable is 2 to 4 times the cost of an overhead power lines. This is mainly due to the limit of physical properties of the insulation placed during installation, keeping the runs of hundreds of meters between splices, which are most commonly placed in manholes or splice boxes for repair. Second, whereas finding and repairing overhead wire breaks can be accomplished in hours, underground repairs can take days or weeks, and for this reason, redundant lines are run. Third, operations are more difficult since the high reactive power of underground cable produce large charging current and so make voltage control more difficult. Friends, there are many cable types, so listen patiently about the cables. Cables are classified into following broad categories according to their usage. First, wiring cable, sheathed and unsheathed. This we have already covered in another slide presentation. Second, power cables, armored and unarmored. Third, signal and control cables. Fourth, flexible cables. Fifth, coaxial cables. Sixth, trailing cables. Seventh, fireproof cables. Eighth, enamel cables. Now we'll work on these cables, different types, one by one. Wiring cables are generally used for indoor applications, for domestic and industrial wiring with separate mechanical protection. Their voltage rating is limited to 1.1 kV and sizes up to 50 square mm. This is very important. They are available only up to 50 square mm. We'll continue this in two more slides. Friends, we are working on cable selection. The cable selection can be from various angles: electrical, thermal and mechanical properties. Electrical properties include dielectric strength, conductor material, those these two result in power loss, impulse voltage withstand capacity, inductances, and current carrying ability is determined on temperature, size, and metal of the conductor, on which voltage drop is also dependent. The thermal property determines the current rating, fire resistance, heat dissipation rate. Next is mechanical properties. Mechanical properties determine insulation resistance, tensile strength, moisture sensitivity, radius of wind, and degree of protection. Now we'll work on cable selection on from electrical angle in another slide. Cables can be classified based on their insulation type. First and most used is polyvinyl chloride PVC cable. Second, cross-linked polyethylene XLP cables. Third is fire retardant low smoke, in short known as FRLS cables. Fourth, low smoke zero halogen and LSF cable. Cables are available with both thermoplastic and thermostatic insulations in PVC and XLP. Now, the cables which are approved by BIS, Bureau of Indian Standards, and therefore by our other systems. For PVC cable, IS 1554 Part 1 is applicable, and for XLP cable, IS number 7098 Part 1 is applicable, and for 66 cable, IS 4098 Part 3. Then for PVC cable, Part 2 is also applicable. For XLP cable, Part 2 of 709 is also applicable. According to voltage rating, the cables are grouped in various portions. First one is LT, or so to say MV, medium voltage, up to 1.1 kV. ST, high voltage, HV system up to 11 kV, ST super tension up to 33 kV, EST extra high tension up to 660 kV, and oil filled and gas pressure filled up to 132 kV, and radium cured XLP cable up to 275. So this in increasing order of the voltage cable classification. Let us go into further detail what some more things are necessary to understand. Aluminum versus copper cable. Copper conductor cable are of the same construction that of cables with aluminum conductor, except for high tensile strength, super, superior conductivity, better flexibility, and ease of jointing. Copper cables are used in control, instrumentation, winding, submarine, mining, and ship wiring, etc. Cable applications available with both aluminum and copper conductor. They are manufactured with solid, stranded, circular, shaped aluminum and copper. Stranding of conductor is necessary for the reason is that the current mostly flows in the exterior category of the cable. The interior portion is of no use. So we string them to increase current carrying capacity. Strengthening makes cable flexible and easy to handle while shaping. They, uh, they may come in different shape, flat shape, circular, sector shape, uh, make them compact also. Standards for conductor. All conductors for cable are manufactured strictly in accordance with the national and international specifications. National specifications as Indian Standard 8130 and International Specification IEC 60228 or BS 6360. Friends, we are talking conductors here, not cables. The cables can be single core, twin core, or three core. In three core cable, all the conductors have equal cross-sectional area. Three strands are RYV. They have equal area. This one, and this one. See the conductor portion. This, and this. Now here the inside is copper conductor or it may be aluminum. The blue, this exterior portion shows PVC insulation. This is PVC inner sheath. This is sheathing all around, and PVC outer sheath is this. So clearly understand. We have stranded cables. We have PVC insulation. We have PVC inner sheath, this black one, and we have PVC outer sheath. Friends, we have generally and mostly 3.5 core cable. 0 0.5 indicates half. So three conductors are having the same cross-sectional area and are used for three different phases. And they have neutral, which is treated as half conductor and has the name 3.5 core cable. The half portion is used to carry the neutral current. So you can see here, this is man, This is man. These three sector shaped are carrying R, Y, and blue phases, three phases. But the neutral goes in the this half portion. That's why these are known as three and a half core. Four core cables are used in very much unbalanced load, so neutral carries more current and therefore it is made of equal size. So there will be four different uh, portions, equal portions, three carrying the three different phases, and the green one carries the uh, neutral, this one. Friends, when we say cable, it is generally meant armored cable, and these are laid underground. So a armor is put, which gives it strength. When we don't say armored, then we say wiring cable. The armored cable consists of one or two layers of galvanized steel wire or steel tape. There can be steel wire, circular one, or it can be tape, steel tape. It is used for protection against mechanical injury. That is the main reason. Now we'll see the different part of a armored cable. The outermost, there is a PVC sheath, then winding tape over that, then aluminum wire, then bedding is used, then copper tape is used, for insulation shield is used, then comes the main insulation and copper shield. They have different purposes. We'll work on that. Friends, unarmored cable are also used in higher rating, but they go in such places where mechanical protection is not necessary, uh, be, uh, because they are cheaper than armored category. The construction of unarmored cable are same as that of armored, except for that unarmored cables are not provided with armoring. Unarmored cable also consists of all parts such as insulation, metallic sheet, welding, and serving. Friends, we are discussing the various components of the cable. Apart from the conductor and insulation, the cable has got bedding, a protective cushion, often PVC, between the insulation and the armor preventing damage. This is also known as inner sheathing. Armor, the metallic layer, steel wire armor, SW steel wire armored, or aluminum wire armor, AWA, providing robust mechanical protection against impacts, crushing, and rodents. The outer sheath, also known as serving or outer jacket, the final external layer in case of PVC, PE, or LSZH, that is, seals the cable, protecting it from moisture, chemical, ultraviolet, and abrasion. The outer um, is also known as serving. Friends, uh, the cable, armored cable is also provided with metallic screen or shield. It is copper tap or wire screen. It provides earthing path, protection against electrical interference. It provides fault current return path. Then in case of MV cable, armored cable, laying up or fillers. Fillers are provided to fill up the gap to make the shape circular. The filler quality has to be non-hygroscopic material. It maintains circular shape of multi-core cables, provides mechanical stability. Third, inner sheet, also known as bedding. It is of usually PVC or PE, polyethylene. It protects insulation and cores, and it makes base layer for armoring. Friends, in case of HV and EHV cable, some more layers are to be provided. The first one is known as conductor screen. Thin layer of semi-conducting material ensures uniform electrical field, prevents stress concentration. There is one more insulation screen which is provided in case of high voltage or extra high voltage cables. Semi-conducting layer over insulation improves dielectric performance, used mainly in XLP cables. Friends, this slide shows the commonly used cable, whether armored or unarmored. Armored in case when it is laid underground, and unarmored when it is laid on the surface of protected places. The first, the first three, 2 into 6, 2 into 10, and 2 into 16 cable are used for providing submain circuit to SP and DV, which are always prescribed by CPWD. Then remaining cables are 3.5, 25, 35, 50, 70, 95, 120, 185, 240, 300, 400, and 600. These are always 3.5 core. That means 3 phase wire and 1 neutral wire, which is half the cross section of phase wire, approximately. Now we use these cables for TP and DVs of several sizes and otherwise for MAN circuits. This is used in TP and DV of 3 phase, and remaining are used for MAN wire, MAN cable. The over 600 we don't have 3.5. It is always single core cable. These cable sizes have been created in a manner that the just below size is half in square meter area of cable conductor. Friends, I have taken this uh, popular sizes of cable from Havels Limited, which are the largest industry in cable nowadays. And this column 1 shows the application, column 2 shows type and size, and this provides the column 3 provides option portion of this one, and column 4 shows the cross section. Now you will notice that heavy duty XLP power cable has got a circular cross section, and they are available only in three core, and remaining space is filled by fillers. These are the filler materials here. This white one, this white one, these are the fillers. Now the first one is cable for power supply to residential and commercial units. Second is for heavy duty XLP power cable for power generation and distribution. Third one shows aerial bunch cable. These are the cables which utilize the overhead poles, and they are clamped from one pole to another pole, but uh, they are insulated. They are not naked, and they are provided to prevent uh, uh, sitting of uh, cows, sitting of the birds and similar creatures. Then next category is fire survival cable. These are used for firefighting purpose and provided in hazardous area. And these cables are largely provided in tunnels, in tunnels of metro stations. Then we have next category solar cable, which is uh, uh, used for distributing solar power, connecting. These are flexible tint copper wire having cross-linked insulation, and they are used in solar panels. Then we use copper cable for switchyard control, relay equipment, etc. Some more cable to come in next slide. Friends, the most used category of cable is polyvinyl chloride PVC insulated cables. They have proved integral to all distribution network in low tension fixed installation. They are also used as control cable for process and manufacturing industries and in mining industries involving fixed installation. PVC cables are manufactured according to Indian standard 1554 part 1, uh, used up to 1.1 kV grade. All cables have ISI certification. PVC cables are suitable for continuous use between 30 to 70 degrees Celsius and up to 85 degrees Celsius for heat resistant applications. PVC is the most accepted plastic material for cable insulation for low and medium voltage grade, as it has got better mechanical, electrical, weatherproof, flame retarding and chemical resisting properties. It is superior because it is strong and made for easy handling, resistant to water, moisture, oils and chemicals, PVC black compounds can resist ultraviolet degradation, especially formulated PVC is flame retardant and reduces emission halogens. Friends, now we are talking of XLP cables. In India, PVC has been dominant insulation for LT power control cables since 1960. XLP emerged during 1970 as cable insulant for low tension, that is medium voltage, and subsequently high ST, that is high voltage cables, as the most economic solution for high efficiency and total reliability. Since the last decade, LT XLP cables have become very significant among the industrial user on account of their excellent features. XLP cable was developed in late 1970 to overcome the susceptibility of PLIC cable, paper insulated cable, to ingress of moisture. Hence, the advent of XLP cable marked the beginning of gradual but steady replacement of paper insulated cables in almost all voltage applications. XLP cables command an immediate acceptance in the view of excellent thermal and electrical properties, easier handling and jointing procedure and maintenance. XLP cables are to be manufactured according to Indian standard 7098 part 1. The advantage of LT XLP cable are: first, low dielectric loss; second, higher power rating and higher emergency overload rating; higher current rating, higher short circuit rating, approximately 20% more than that of PVC. Third, superior short circuit rating. Fourth, much better insulation resistance, 1,000 times more than that of PVC. Fifth, high resistance to moisture, that is 100 times more than that of PVC. Capacity to withstand localized hot spot temperature, very vital to steel plants, power stations. Comparatively higher cable operating temperature at 90 degrees Celsius and short circuit temperature rating of 250 Celsius against resistant to chemical and corrosive gases. Exhibits better properties such as resistance to vibration, impact, aging, and hot deformation. We'll continue next slide. Friends, solar cables. Solar photovoltaic industry gets more attention as the most promising environment friendly industry, and it is expected to have the significant role in resolving the earth energy problem. As production costs diminish, users increasingly view these energy sources as clean, cheap, and reliable. Special properties of solar cables: lifetime reliability, last up to 30 years. Now, outdoor durability, extreme temperatures, it is vulnerable between minus 40 to 120 degrees Celsius. Ultraviolet resistance. It is halogen free, low smoke emission and low toxicity, corrosivity during fire. Properties against fire, flame retardant and fire retardant. Flexibility and strippability for fast and easy installation. Fully recyclable in accordance with new environmental regulations. Easy installation with color identification blue, red. Suitable to common connector types. Friends, this slide shows the technical details of 1.1 kV 3.5 core aluminum or copper conductor PVC insulated armored cable. This shows the first column shows the size detail and second column shows the strands in the conductor minimum. It may be more also. Similar details are given here. Friends, in the previous slide, we have seen the physical properties of the cables. In this particular, we are seeing technical details for 11 by 11 kV single core aluminum or copper conductor XLP insulated armored cables. This gives first column gives the sizes, and you can see the normal current rating for aluminum and copper in three different situations: ground, duct, and air. These are nominal current ratings we can take care of. Similarly, short circuit capacities. Now we are learning selection criteria for medium and high voltage cables. The conductor size in the cable for any installation is always governed by its ability to carry short circuit current of system. For LV distribution cable may be selected on the basis of continuous load current, but in case of medium voltage and high voltage distribution, it is always safer to select the cable on the basis of its ability to carry expected short circuit current. Short circuit current rating of cable should be in line with the short circuit capacity of damping apparatus such as circuit breaker, transformers, and reactor, beside its own capacity to carry desired load and current short circuit rating of cable. 1. Temperature of conductor just prior to short circuit with XLB insulation 90 degrees Celsius. In case of PVC, it was 70 degrees Celsius. Maximum permissible conductor temperature during short circuit. For XLB, it is 250. PVC, it was 160. Volume specific heat of conductor, volumetric. With aluminum conductor, it is 2.5 multiplied by 10 raised power 3 joules per degree. With copper, it is 3.45. Now we'll see reciprocal of temperature coefficient of resistance at 9 degrees Celsius. With aluminum, it is 228. With copper, it is 234.5. Short circuit rating of different duration may be calculated as the formula as per formula. Selection criteria of high voltage, medium voltage cable for primary consideration. Required data. Nominal system voltage ST side 11 kV. Short circuit level for ST system to 25 kiloamps. Fall time for ST circuit breakers 0.5 second. Formula for calculating ST cable size with aluminum, it is ISH multiplied by root 3T divided by 0.094. So as calculated, it comes 188 size of the cable 188. So hence nearest higher size is 244. We'll select this cable. With copper XLP insulated cable with the same formula, the cable size comes 124 square mm. So next size of 150 square mm is selected. Friends, in this slide we have two tables provided here. First one is for calculating estimated voltage drop in PVC or XLP aluminum cable for AC system. The first column shows cable size, second column shows voltage drop in volts per kilometer per amp. So we have to apply the distance, then apply how much amperes. So in case of PVC, there are two columns, single and three phase, same two columns for XLP cable. This second chart here gives you various formulae for calculating kVA. When kVA is given, calculating the other similar load current in amp when kilowatt is given and when HP is given. So we can calculate different properties. Friends, this particular chart or table provides power current rating of with conductor of different type. So first column shows the size of cable. The second column shows current rating of building wires in case of wires. The third column shows the three and a half and 4 core 1.1 kV PVC cable with aluminum and copper conductor. These are the current ratings. The second column shows 3.54 XLP cable. This was PVC cable. This was XLP cable. Similarly, this shows for higher ratings, higher voltage, 3.3, 6.6 and 11 kV. So we can select for both PVC and this is for the XLP cable and this is for unearthed XLP cable. So these current ratings are nominally, and let me tell you frankly, this chart I have taken from Havel Industries. They are the largest electrical nowadays in India. This particular table shows you current rating of copper armored or unarmored cable up to 1100 volt grade in air. These are the amperes with respect to various sizes of cable. This chart is given by polycab cables. Friends, quite often we deal with electrical motors, and this chart gives you estimated full load current for motors, induction motor. When we say motor, it means induction motor for different horsepower or kilowatt rating. What will be the load current for different sizes?